קבלו בבקשה את דוקטור אליסה וולש.
Okay, it's very nice to come and talk to you today about omega-3 fats, and I'm particularly going to, I'm afraid this is much less lively than some of what you've seen, and I'm really now talking about the science of omega-3s. So, sorry, I'm just waiting for this to go to the next. Okay. So, in terms of what we call omega-3s, oh, thank you very much. Omega-3s can also be called N3-PUFA, and I'll be talking about the importance of them. Thank you. And what we know is that they are essential to us as humans. We need them for our health, and we know that if you that essentially they are part of us, and they're integral to membrane structures. And this is the. So if you see this picture here, this is a picture of a membrane and some of the processes that go on in using omega-3 fats in the body. I'm not talking about those today, but essentially membranes are the bits that are all of us, so our skin, our blood cells, and all those parts of us, so that they belong to that. And potentially, omega-3s can help us reduce the risk of chronic and inflammatory diseases. And examples of this are coronary artery disease, and also dementia, diabetes and asthma, although the evidence is quite a lot weaker. So the main sources of the omega-3 fats, EPA and DHA, are fish and fish oil supplements. And these are also called long-chain N3-PUFA. But as we know, if we want to eat fish, there are issues with sustaining the supply of fish, because we do a lot of fishing, we've been overfishing the oceans, the fish supply is dwindling. And also not everybody likes fish or wants to eat fish, and then there's a problem with that. And certainly in the UK, somewhere between about 15 and 44% of people consume oily fish depending upon who they are, so it's not very large numbers. And if you go through Europe and look at variability in the amount of fish that people eat, it's quite high. So it's about 6 times difference between the low consumers and the high consumers. So in Germany, people are eating very little fish. In Spain, people eat a lot of fish. And in the UK, we're somewhere in the middle. So ideally, if we could find types of omega-3s that were readily available and renewable, and didn't come from fish, this would be very useful. And so alpha-linolenic acid, or ALA, is a plant-based omega-3 PUFA, and this is called a short-chain one. And basically, we can get this from a number of places. So we can get it from foods such as walnuts, flaxseed, hemp seed, rapeseed oil, and their oils. And sometimes rapeseed is also called canola oil, particularly if you're from the States. And also you do get certain amounts from green leafy vegetables and from soy oil. So what about if we're not eating EPA and DHA in fish oils? What happens? Well, there is some conversion from ALA, and this goes through these stages here, through ALA, through to EPA, DPA and DHA. But essentially, and there are a number of enzymes that are involved in these pathways, but essentially conversion stops here, by and large. But fortunately, if you're younger, then you convert more. If you're a woman, you're likely to convert more, particularly if you're of childbearing age. But interestingly also, smokers seem to convert more, and we don't quite know why, but it might be because it stimulates these enzymes. The other thing that will inhibit the conversion is this N6-PUFA, or linoleic acid, and they're very common in the diet, so they work against the conversion. And then also, perhaps, we think that maybe just EPA and DHA alone might inhibit this process through to the end point there. So I became interested in this because I was looking at intake of fish and how much omega-3 people had in their blood and relating that. And I realised that actually what was interesting was that people who weren't eating fish still had quite high amounts of omega-3s in the blood, and it wasn't quite clear why. And this this graph shows you the information. So this was the amount in the blood, and this is the categories of how much fish people were eating. So you can see this is nothing, or eating very little, no fish, and then this is categories divided into three. And you can see that if you look at the lowest category, there is still quite a lot of this omega-3 in the blood. And if you go up to the top, there is a gradient. You can see there's a difference. But actually this difference is only about 20% or a fifth. So it's not between 0 and 100 or anything like that. And I took care of all the things that might affect the conversion that I mentioned. So age, how old the people were, whether they were smoking, whether they were taking fish oils. And then I looked around the literature and thought, well, is this an unusual finding, or is there something, what about this? And I found a number of studies that had similar results. So this is another study that shows you fish intake here, going up by the amount per week. And then this is the amount of the DHA in fat, in the body fat. And then you can see that basically there is a slope, but actually it's very shallow. And this is no fish, and then this is quite large amounts of fish. But the difference is only really very small. So there is something going on. So what I did was investigate this further, because I thought, well, what about the people who aren't eating fish? Are they in trouble? Is there a problem for them? And so I decided to try and make an estimate of using statistics to try and find out whether they might be potentially converting more of this ALA to the longer chain fats. And I had fish eaters, and I divided my data into fish eaters, and then people who weren't eating fish, but they might have eaten meat, or they're vegetarians or vegans. And I took this data from the study I've been working on for many years, which is a very large study, which means that it's called a cohort study, which means you look at a lot of people, you take a lot of information, and then you find out what's happening to them. And these are 25,000 of those, men and women, aged 45 to 74, who are part of a very big study in Europe of 500,000 people in 10 countries. And I analysed my data in about just under 5,000 people. And so I was thinking that perhaps if conversion was greater, I might find greater conversion in non-fish eaters than fish eaters. And also I took care not to include people who were taking fish oil supplements in my analysis. So these are the data for status and intake, and it shows you the information for the different groups of the way people were eating, whether they're fish eaters or non-fish eaters, meat eaters, vegetarians and vegans, men and women. And you can see that the fish eaters were about quite a lot of the population were fish eaters in terms of percentages, mostly fish eaters. About 15% were meat eaters, and then smaller numbers of vegetarians and vegans. And looking at the amount of the total N3s that they were consuming varied between about 0.9 and 1.5 grams, and smaller amounts in the women. And you can see that ALA, this is the amount of ALA that was contributing to the amount in the diet. And so basically for the non-fish eaters it was mainly ALA, but even in fish eaters it was about 80% of intake. So then I was looking at the amount in the blood and comparing that, and you can see that obviously it's greater of the N3-PUFA, it's greater in the fish eaters, but much smaller in the non-fish eaters. And actually, interestingly, which I found before and other people are beginning to show, that actually in women for the same amount of N3-PUFA, the levels are higher than they are in men. So, okay, so where are these, where is the ALA coming from in the diet? Thought it would be interesting to know. And this is looking at data from the people who were eating meat and the vegetarians.